Hi, I'm David Abrams, and today we'll walk through a calibration on the LG G2. But before we get started, it is important to note that while we are calibrating the LG G2, which is a 2022 model, many of the methods and process may be applied on the other model years. Additionally, the purpose of this video is to provide guidance, but there are certainly other approaches. For example, today we'll be calibrating in SDR, HDR, and Dolby Vision in the cinema picture modes, but Calman supports working in other modes such as game or filmmaker. By the end of this video, you will be able to use what is discussed here today and apply it to your own workflow. Let's get started. First, let's start by reviewing the potential approaches one may take in calibrating the LG. To perform a calibration, we require three things: a test pattern source, a measurement device, and Calman calibration software. To reduce the need to purchase all three, Portrait Displays has worked diligently with the team at LG to include a built-in test pattern generator. We'll talk more about that shortly. For now, let's take a look at our system. Today, we have the Colorimetry Research CR300 spectroradiometer paired with the CR100 colorimeter. We've got that connected via two USB cables to a Calman system running on Windows below. The test pattern you're seeing on the screen is actually generated by the VideoForge Pro sold by Portrait Displays. On our computer here, we're running Windows in a remote desktop. And we've got our C6, which also works with Calman. So while we're working with the Colorimetry Research meters here today, you can use any meter supported by Calman when you perform this procedure. Let's start by launching Calman. Now, while Calman launches, you may want to do a few things. Right now, I have the TV in its out-of-box state. So if we hit the settings button on the remote, and we come down here to all settings, you'll notice that we're in the picture mode auto power save. When Calman connects, it's going to automatically change this to cinema mode. But I'm going to change this now while everything gets started, and our Calman's already booted. And we're going to go through a couple things on the menu before we even start our calibration. First, let's go down to support. The most important thing whenever starting a calibration with one of these displays is to check for your software update. We've just done this before we got started here today. If we hit check updates, we should see there's no updates found, and we're currently running 03.33.65. It is important to note that with many displays, but not all, a software update could change the color characteristics of the display. It all depends on what's being performed in an update. For that purpose, I personally like to turn off the auto update feature so that when I update a display after calibration, I've already done the research, or I know it's not in a color critical environment where updating the display might mess with my workflow. Let's hit the back button and come out of the support menu. There are a number of things you'll see here in the general menu that you may want to go through. A lot of these you'll want to set up just as you're going to be using the display, but there are a couple things that might help to make the calibration move a little smoother. If you see things like AI Picture Pro under AI Service On or AI Brightness settings, those things can automatically try to adjust the picture even after calibration. It's important to note what's happening. If that's what you'd like to achieve, you can certainly leave those on or turn those on after calibration. However, we certainly want to have these off for what we're doing here today. If we come down, we've got our OLED panel care. Care settings off, device self-care. We'll look here, we see there's an energy saving mode in the menu system. Energy saving step is set to auto. While you, again, may want to have this on after the calibration, I'm going to turn this off for the calibration process to make sure that no energy saving circuitry tries to dim or brighten my picture against the measurements I'm trying to make. We'll come back out there. We'll come back out another menu. Let's take a look at OLED panel care. Here's another area where you might run into some problems. So we have screen move. This is an excellent feature for trying to reduce burn-in on your display. What it tends to do is it tends to move the pixels a few pixels up, down, left, right in order to reduce burn-in. We're going to turn this off for the calibration, although you don't have to. Adjust logo brightness is currently set to low. Again, we don't want anything automatically adjusting during the calibration, so for now we're going to turn this off. However, it's a good idea to turn this feature back on if you plan to have a lot of logos or maybe a stock ticker, you're using a lot of sports or gaming. This will help reduce image retention over time. We'll go back, we'll come down. A nice trick on the LG OLED is if you come here to devices and you go to TV management, if you're setting up your calibration report, you can come down here to TV information and you can find your serial number, model number, and how many hours are on the display. HDMI settings, HDMI deep color. Here you'll see the option for setting this to off or 4K. The HDMI deep color setting often turns on when you go into the HDR mode or Dolby Vision mode automatically, and you'll see a prompt on the display. Currently, we turned on the display with a Dolby Vision test pattern generator going into it, and it already prompted me before we started this video, so you'll see it's already on 4K. You can either turn this on manually, or you can come back to it later when you set the generator to HDR and you do your HDR calibration. Network. This is going to be very important because Calman is going to connect over the network. So right now what I'm going to do is I'm going to come here and take a look at my IP address. I'll get my IP address for the video, and I'll be able to enter that into Calman when we start working on our calibration. System, again, settings you may want to go through for how you want to adjust your display or how you're looking to use your display. It's all going to depend on your environment. Are you using it at home? Are you using it in a professional setting? And moving forward from there. Additional settings. Personally, when I set up a lot of these, I set them up for studio environments. So I often turn the home settings to off so that it can come up just as if it was a monitor. Of course, if you want to use the built-in applications and you'd like to use some of the other features of the display itself, you may want to have these on. So now that we've gone through some of the settings on the display itself and the various workflows you might want to use them in, I'm going to back out of the menu and I'm going to switch back over to my Calman computer. Here, I've come up with my database. I'm going to skip the database right now while I move over to the top menu, Calman, and scroll down to Open Workflow Template. Here, I'm going to go to Display Specific, and I'm going to go to AutoCal LG. Calman's now going to open up a workflow designed for the LG calibration process. You'll notice there are three modes: SDR, HDR, and Dolby Vision calibration. I like to start with SDR calibration. One of the nice things about starting with SDR is that as you calibrate a display, the display tends to heat or cool up based on the content you're using. If you're in high dynamic range or Dolby Vision and you're pushing high nit levels, the display tends to warm quite a bit. When you're trying to calibrate for a lower nit level, you'll need it to cool back down. What I've personally found is most displays on the market today will heat up faster than they'll cool down for stability. So I always like to start with the SDR calibration process when I'm going through this. Okay, hardware connect. As you can see, I don't have any meters, generators, or displays connected here. So I'm going to hit Find Meter. Now keep in mind, I have two light meters. I have the Colorimetry Research CR100 and the Colorimetry Research CR300. So in this case, I'm going to want to connect to both meters. If you look at my window, you'll see all meters except those that are listed below. This is great if you want to start searching through a lot of meters, but I'm going to just select my Colorimetry Research meters, go to my port 4, I'm going to hit Search. Calman is now going to search and connect to one of the two meters. As we can see, it found the Colorimetry Research CR100, so I'm going to hit Find Meter again. I'm going to choose my other COM port, and I'm going to find the CR300. Okay, and we see the CR300 has now been connected. If you want to switch between your meters, you can simply go up to the Open Settings panel here, or go direct, and you can toggle between the meter at the top here. Next, we want to connect to our pattern source. In order to do so, I'm going to hit Find Source, and I can choose my manufacturer. Now today I'm using the VideoForge Pro. However, if you decide to use the built-in test pattern generator on the LG OLED, you'll want to go to portrait.com and our knowledge base. There, we have files that you'll install onto a USB stick formatted for FAT32. Those files will provide SDR, HDR, and Dolby Vision content for calibrating those respective modes. You'll plug in the USB stick and play it through the media player. It's important to have those test patterns because those test patterns actually trigger the modes on the TV. So if you don't have an HDR signal going into the TV is not going to go into the HDR mode. As such, you'll always want to be using a test pattern or an image that's going to allow you to go into the proper mode you're trying to calibrate. Let's go back to the VideoForge Pro and connect to it. We'll scroll down to SpectraCal, VideoForge Pro, and we'll hit Connect. We've now connected to the VideoForge Pro, as you can see up here in the top right corner. Next, we'll want to go to the display. And you'll notice there's also some instructions here on the bottom left that talk about ensuring that energy saving and dynamic tone mapping is disabled for the calibration and validation. We've already gone through that while we were booting up our system. Let's hit Find Display. You'll notice the LG G2 is selected. We'll find the model that we're working with. LG 2022 Alpha 9 C2 G2. That's what we're working with. And we'll type in our IP address. So now we'll enter 10.23.211.221 and we'll hit Connect. Now it's important to note that both the LG OLED and the Calman machine have to be on the same network. they're not on the same network, you might have to find a way to get them on the same network. If you're running a VLAN where your computer's on one segmented network and the LG's on the other, you'll have to bridge those together or put them on the same. The other thing to note is that Calman is communicating over certain ports. If those ports are being blocked by antivirus software or a firewall, you also may need to remove those in order to perform the calibration. For most people though, we find this isn't an issue. As Calman searches the network to connect to the display, notice that a pin code has now come up on the LG OLED. That pin code comes up in order to ensure that the user is actually an authorized user to start adjusting the display. We don't want anyone just logging into your LG OLED and making adjustments. We're going to enter that pin code into the pin window here, 726-874-20. Press OK. You'll notice on the bottom calibration start has happened. What's happening is Calman is going into the display, changing it to cinema mode, and downloading the settings into the controls in the top right of the UI where it says Direct Display Control. Now that we're connected to the display, we're going to press Next. Here, we can set our calibration targets. For now, I'm going to set my targets to D65, Rec 709, and a Power 2.4. BT1886 and Power 2.4 are essentially identical on a display that does a perfect black. Since the OLED can actually turn off each pixel, we're able to get a very, very close, if not near perfect, black level. Let's press Next. On this page, we're prompted with pattern insertion. As I mentioned before, patterns can actually heat up or cool down the display depending on what you're measuring. Calman is very intelligent and has a pattern insertion system in order to regulate the temperature of the test patterns and keep them constant so that the calibration is equal throughout. Here, I'm going to press Set SDR Default. This is going to make sure that the pattern insertion and the pattern stabilization patches are optimized for the SDR calibration workflow. You may find that depending on your meter and depending on your test pattern generator, you want to change these. In fact, you can actually set different exposures on many meters, including the C6 and the CR100. If you set it to a high exposure, you'll find that near black is going to take longer to read. You may get more accurate results, but you're also going to cool the panel down a lot faster. Therefore, you may want to change your pattern insertion to ensure that you're not cooling off the pattern too much. If you set it to a short exposure, you're going to take a much faster read, but you might not get as perfect near black results. It's important to experiment with this to optimize your workflow. The numbers that are in our workflow as a default have actually been optimized for most general use cases. Let's press Next. Here, we're going to take a pre-calibration capture, but you'll notice I'm using the CR100 and the CR300. What I haven't done yet is I haven't optimized my meters for use with the calibration. I'm actually going to take a step here, and I'm going to go up to the meter panel, and I'm going to start setting up my meter. Right now I'm in sync mode auto. Well, on the CR100, that means each time I take a read, it's actually going to measure sync. That's going to add about 1 second to every read. That's not something we want to do. So let's set this to on. And I'm going to set sync meter. Calman's now going to put up a test pattern and it's going to measure sync. Here we've synced to an approximate 96 Hertz. Now that we've done our meter sync, we're going to want to create a meter profile. Here, I've already got some profiles made, but I'm going to go and create a new one. We're going to hit New Edit. We're going to make sure our reference meter is the CR300, the target meter is the CR100. We've already got our sync set, and we're going to come down here to Add Profile. And we're going to rename this. We're going to say CR-300 because I'm making it with the Colorimeter Research CR300. And I'm going to put dash Bodner G2. That's going to be our profile for here. Now what you're going to notice is there's a Generate Profile Matrix. There are two methods to generating the profile matrix in Calman. Here we can select the 4-color matrix method or the Bodner method. The 4-color matrix method is typically used with RGB displays. However, the Bodner method has been optimized for WRGB OLEDs. As such, we're going to use the Bodner method here. So we'll select Bodner, and now, since I have both meters, the CR100 and the CR300 on the same patch on the same display, I can do a single pass. If you had to use 2 meters where you weren't able to measure them at the exact same time, you may do a multi-pass where you move 1 meter in place of the other. And if you're using a meter such as the C6, you'd simply choose the profile that matches your display from the Calman meter menu. Now we've made our boundary method, I'm going to hit close on the window. You'll notice at the top now, the profile name CR-300-Bodner-G2 is illustrating that that is what profile Calman is using while I measure the display. Let's come down to the read series on the bottom and press read. Okay, as we can see from the pre-calibration, we can see that the colorimetry is a little outside the desired gamut. We're going a little warm with our color temperature, and our deltas are measuring a max 4.3 with an average of 3.2. And on the color, we're measuring a max 5.5 with an average 4.2, and our EOTF is slightly not tracking to our target. Let's press next. Here we want to do a display reset. We're able to reset in SDR the Cinema, Expert Bright, Expert Dark, Game, and Filmmaker mode. We're going to stay in SDR Cinema for now, and we're going to hit reset. This is going to turn on Cal Start, which is going to check the Enable Calibration box. It's going to go through the process of uploading a 1D and 3D Unity LUT so that we're able to perform the calibration by loading new lookup tables in the display to optimize picture accuracy. Now that the reset's done, let's press next. At this point, I like to actually go through the menu and turn off anything I find I might not want on the display. So I'm going to hit Settings. We're going to go to All Settings, and I'm going to come down here to Advanced Settings. Another tip, though, is going to the aspect ratio. In 16:9 mode, and just going to set to auto, you may find that you have overscan at times. In order to reduce the overscan so the image doesn't go off the sides of the screen, you can set this to on. I personally like using my display with this set to on, or any display with it set to on. I personally don't like overscan. Let's go to our Advanced Settings, Brightness, and let's look if there's anything we'd like to change here. Most of these are going to get adjusted during the calibration process. You'll see there's a video range setting set to auto. The Video Forge Pro is excellent at setting metadata for full range or narrow range, where the auto mode works very well. If you're finding that your generator isn't putting it in the correct mode, you may set it by manually selecting limited or full. Limited being for video or narrow range, and full being your typical full range format. Let's hit back, come down to color. You notice that color gamut is grayed out. Color gamut is going to be grayed out when a LUT is loaded, whether that's a Unity LUT or a calibration LUT. If you ever notice that this is not grayed out, it means that a LUT is not being loaded from a calibration system. Let's hit back, and let's check clarity. Clarity. We'll notice that super resolution, noise reduction is on. While these won't affect the calibration during the calibration process, I personally like to turn these off. The test pattern generator is an excellent signal, doesn't have any noise in it, and come down to our true motion. Now, true motion might have some form of interpolation or image processing that happens. Personally, I like to turn this off, which will then enable Real Cinema. Real Cinema allows the display to process 24 frame per second content at a multiple of 24 frames per second. I personally like having Real Cinema set to on. Let's hit our back button, and let's come back out of the menu. Now what you'll notice is since I was measuring sync with true motion set to on, we had a sync signal of 96 Hertz. But since I've changed the display's characteristics by changing some of these settings with the motion, let's take another look at what our sync is going to be on our meter. We're going to click on the sync in Calman, and we're going to hit Initialize Meter. You'll now notice we're running at 119.9 Hertz, or close to 120 Hertz. The LG OLED is a 120 Hertz panel. We're now measuring sync closer to the panel's native refresh. Let's go back to our Calman. Okay, so now we've set up our user menu. We've got our sync set with our colorimetry research. The next step here is going to be setting our peak white to the desired value. You'll notice in the instructions it says adjust the peak white for your display to be about 15% brighter than your actual target. Well, in a post-production environment and many environments, I want to set this to the BT709 standard of 100 nits. So let's take a measurement by hitting read, and let's see where we're at. We're at 277.1 nits. We're actually quite bright here. Now you may remember that we were at about 80 in the user menu when we went through our settings. I'm going to take this down to about 35 and see where we are. I'm going to want to be around 115 to 120 nits in order to be at that about 15% value. So we're at 148. We're still a little high. So I'm going to take this down to 30 and hit enter. It updates the TV as we adjust it. We're at 134. The G2 is very bright. We come down to 25. Let's see where we are. All right, we're at about 117.7. So that's about 15% brighter than our desired target. We'll hit next. And let's perform our audio cal. So you'll see here it says press the auto cal button to select SDR points to the auto cal, the 1D LUT. There's a couple tricks you might want to take into account here. If we come up to the settings menu, we're in the BT709, power 2.4 video. If we click on workflow options, you'll notice we have use measured black level, or we can set a black level. This really depends on your workflow and your meter. If you're using a high quality meter that can measure near black, you may want to use the meter to measure black. If you're using a meter that may not have very good near black performance, you may want to set this to 0.0 versus getting erroneous data that may inadvertently lift up the black level when we're trying to track a near perfect 2.4. For now, I'm going to leave this in the use measured black level, and we're going to hit auto cal. Okay, so you've seen the auto cal setup window come up, and you'll notice that we have active grayscale points we can select from. Calman has run through a couple test images, and it knows that the range is 16 to 255. As such, the default value here came up with LG 26 points, SDR 16 to 255. That accounts for super white information. At this point, we have an option. We can either do the default, which is the most common, or we can scroll down to the bottom, and you'll notice there's an LG dark detail SDR 16 to 255. There's also a 16 to 235, but since our generator is measuring 16 to 255, we'll select that, and we can change our delta target if we want to target a tighter tolerance. You'll find that if you target a tighter tolerance, the calibration is going to take significantly longer, but you may get tighter results. If you target a more relaxed tolerance, such as setting this to delta 1 or delta 2, you'll find that the calibration process goes significantly faster, but you'll often have a higher level of error. For now, I'm going to leave it at the delta target of 0.5, and we'll hit OK. Now I selected the dark detail because I'm using a Colorimeter Research CR100 colorimeter that has very good near black performance. So by selecting the dark detail, I should be getting a little more precision in my near black and how the display performs coming out of black. Although you may notice we're in a studio environment, and the studio environment is just a little bright. So I don't expect these results to be perfect because there is some light reflecting off the screen as well as probably into the meter. But you get the idea of what we're trying to achieve. Okay, so Calman has finished its auto cal process. It took about 17 minutes, 16 seconds, and went through about 82 reads. We'll notice now that Calman calibrated at 109% to about 121 nits. If we come down to 99%, we're at 97 nits. So we'll probably have to adjust our luminance as we go through the calibration process here. Let's click Next. And now we're at our 3D LUT calibration process. This is where we're going to adjust the color gamut mapping. I'm going to hit Auto Cal, and we're going to get some options from the Auto Cal menu. Here, we've got the ability to set a start delay if we want to leave the room, turn the lights off, and potentially, make everything dark and not be in the room when the calibration starts. If your room's already dark and you don't have to worry about that, you don't need to set the delay. We can also hit Set 3D LUT Grayscale to Unity. This is a good idea in SDR because we've already done the 1D LUT calibration, and what's going to happen is a 3D LUT also has luminance data or grayscale data in the LUT itself. So now that we've corrected, what we'd end up doing is correcting a second time. Now that's going to change for HDR, and I'll explain a little bit about why, but for this process, since we're doing a multi-point 3D lookup table and we've done a multi-point 1D LUT, we're going to keep this set to on. Now we have different options here. We have a lightning LUT, matrix ramp LUT, a fixed grid 9-point, fixed grid 13-point, 17-point, 21-point, and a matrix LUT. It's important to note the more points you do, the longer the calibration is going to take. So you'll want to judge the amount of time you have to perform your calibration against the amount of accuracy you want. I personally find the fixed grid 9-point or the fixed grid 13-point offer the best balance of performance and time savings. Here, for the purpose of this demo, we're going to do a lightning LUT. You'll also notice the video range is set to SMPTE plus 16 to 255. Once again, it's set the same way the 1D LUT was. If you notice it wasn't, you may have an issue and you may want to check all your settings. Let's press OK. Now, because we're calibrating in a high ambient light environment and we're only doing a lightning LUT, we don't expect these results to be the best that Calman can deliver. For that, you'll want to make sure you're in a darkened environment, and you may also want to use the fixed grid 9-point, 13-point, or even higher to get the most ideal results. Again, this is going to depend on the amount of time you have and how accurate you want your display to be.
Very well done.
All right, so the Aurora Color Engine has completed its calibration. You'll see the time elapsed for the lightning LUT was 10 minutes and 19 seconds, and it took 101 reads. We'll hit OK, and let's move on to the next page of the workflow. And now we'll want to verify our luminance. We targeted about 15% over our target luminance, which was 100 nits. You may remember we were at about 117 nits when we started. But the calibration process will inevitably reduce the luminance. So let's take a look at what we're measuring now. And we're measuring 96.5 nits. So I'm going to come over here, I'm going to hit the plus sign. I'm going to go up one, measure again. Now, we're keeping the pattern insertion running while we do this. We're at 99.8 nits. I'd say that's pretty close to 100 nits, and I think if I hit one more and bring this up to 27 on the OLED light, we're going to overshoot our 100 nits. Yes, we're at 102.7 nits. Now, personally, I rather go above my nit target than below my nit target. I always like to shoot over in these situations just because the set might dim over time, there might be some fluctuations, and being a little high tends to be a little more pleasing at 100 nits than being a little low. But of course, you need to make your own decision. Let's press next. And now we're finished the calibration. We're going to uncheck the enable calibration box, and the TV is going to come out of the calibration mode. Let's press next. And let's take our post-calibration readings and see how things came out. Okay, so as we can see, we're now tracking a grayscale with a max 0.7 Delta E 2000 and an average 0.3, as well as a color gamut of a max 0.7 and an average 0.5. So both of our Delta E metrics are under 1 across the board. It is important to note that we've only measured the 100% here, so you may want to do some additional validation. Let's hit next. So now we have the option to do that additional validation, save out a report, or calibrate the next mode. Let's take a second to do the additional validation and see how our calibration really came out. Now again, I don't expect these results to be perfect because we are in a very high ambient light environment with lights next to me that are shining on the screen, and we're also only doing a lightning LUT. But what we hope to have is excellent results for the situation that we're in. All right, so as you can see, we've got a max delta E of 3.2 with an average of 0.1. We've got a couple colors here that are peaking, and we can also see this on the chart on the right. And once again, we are able to get much, much better results. And I know some of you may say, well, then just do it. Well, we can take the time and do it, or we can walk through the next mode. So let's go ahead and let's measure HDR. But I do encourage you to try those fixed 0.9 grids or fixed 0.13 grids because I do find that those produce excellent results in a reasonable amount of time. So let's hit next, and let's take a saturation sweep. Okay, so we finished our saturation sweeps, and we'll see we have a max 2.7 delta with an average of 1.1. And we can see some of this error here in the red that's happening and in these middle range saturation sweeps. Again, I think this is mostly because, one, we did a lightning LUT, which is a little fast, but the lightning LUT's also going to be affected by these really bright lights that are surrounding me, and those are going to have an effect on the results. Let's press next. Okay, so we finished our calibration, and now we can hit save and report, calibrate the next mode, or additional validation. Let's go ahead and calibrate the next mode. Here, we're taken back to the start of the workflow, and we have our SDR, HDR, and Dolby Vision calibration. Typically, I like to walk through this in order. Let's hit HDR Calibration. We're brought back to our same page, Hardware Connect, Pattern Source, and Connect Display. Well, we're still connected to our meter, and we're still on the CR100/200, so we don't have to connect there. We're already connected to our SpectraCal VideoForge Pro, and we're already connected to our display. But you'll notice that there's some settings here that we may want to do to optimize the system for the HDR calibration. Let's hit Open the Settings panel, and let's choose HDR on our VideoForge Pro. Now, you're going to notice that the generator goes in HDR, and you should see on the display the HDR signal in the top right corner. That lets us know that the display is seeing the HDR signal and going into the HDR mode. If you're sending an HDR signal, or you believe you're sending an HDR signal, and you don't see the HDR mode come up on the display, you can take the remote press the settings button, go down to all settings, picture, and you'll see HDR select mode. If this wasn't in HDR, it wouldn't say HDR. If it was in Dolby Vision, it would say Dolby Vision. Because this is HDR, we know we're getting an HDR signal and the display is processing it in an HDR fashion. Now, let's back out of the menu and let's come back to Calman. You'll notice on the Connect display, we have SDR mode, set the color space to 709, but in HDR mode, we want to set it to BT 2020. Let's set this to BT 2020 and let's click HDR. We're going to hit next. We can set our targets here for what we'd like to calibrate. Currently, Calman has set this to D65 Rec 2020. We're going to start with the D65 Rec 2020 mode. That's typically what HDR is in. For those of you in the post-production community, we're also going to go through some tips and tricks to set this up for a P3 D65 HDR workflow for content creation. Again, you wouldn't want to use this at home, but you will want to use it in post-production environments where your system is set up for P3 D65 in an HDR fashion, SD2084 or the PQ curve. Let's press next. Once again, we're at our pattern insertion and pattern stabilization page. Instead of being set SDR as the default, we're going to set HDR Dolby Vision default. You'll notice as I press this, the frequency, duration, and level will change in these columns, as well as the patches, duration, and level. Once that's finished, we'll click next. Now we're on our pre-cal capture again. You can see the calibration data on this page from the previous calibration. If you want to clear that data, you can right-click on History 1 and hit Clear Tab Data. If you want to set up a new tab, press the plus sign and you can keep History 1 and set up History 2. Let's take some pre-calibration readings just as the display is. Okay, so we've performed the pre-calibration process, and you'll notice we're actually tracking above the PQ-EOTF curve, and we've got some saturation differences as well as some grayscale differences here. Let's hit next. And now, once again, we're at our display reset. So since we're in the HDR picture mode, we're going to want to set this to HDR. Now, once again, I can do HDR Cinema, HDR Game, HDR Filmmaker mode. However, I'm going to set this to HDR Cinema. So one of the things I like about using the cinema mode is there's actually a standard dynamic range, or an SDR cinema mode, a high dynamic range cinema mode, and a Dolby Vision cinema mode. Not all picture modes are available in both SDR, HDR, and Dolby Vision. For example, Filmmaker mode isn't available in Dolby Vision. Therefore, it's very easy for you or your customer or your colorist to know which mode they're in by just setting everything to cinema. Cinema, cinema, cinema. Nice and easy to remember. Now that we've set our set to HDR Cinema, we'll want to do the reset. We'll hit reset. It's going to go into the calibration start mode. It's going to do the reset. It's going to load those Unity LUTs in, and then we'll take another look at our menu to make sure things are the way we would like them to be. Let's go to settings, all settings. We're now in the HDR select mode Cinema. If we come down to advanced, we can take a look at how things are been adjusted. OLED pixel brightness 100. Dynamic tone mapping. Now, when you're in the calibration start menu, dynamic tone mapping is disabled. However, in typical situations when you calibrate a display, you may want to have this off. You also may want to have it on. I personally like setting it to off for most of the use cases I work with, and it'll stay off after the calibration process as well. Again, we have our video range setting. Right now I'm in auto, and we're calibrating in RGB limited. So the display should be in narrow or video range, limited range. And our motion eye care is off. Let's come down to color. Once again, we can see our color gamut is in wide and it's grayed out, meaning that a LUT has been loaded into the display. Let's come to clarity. And we'll notice noise reduction's on in HDR. We'll set that to off. MPEG noise reduction is on. I'm going to set that to off. And True Motion is off and Real Cinema is on. Let's exit the menu, and let's move back to Calman. We'll hit next, and let's do our Grayscale Auto Cal. Once again, we're going to hit the Auto Cal button in the lower right corner. Calman is going to take a couple quick readings to ascertain what's going on with the display, what range it's in, and then we're going to get a prompt to set our active grayscale points. So once again, you'll notice Calman automatically puts us in LG 20 points HDR. It's putting us in this range because it correlates to the mode that we're in, and Calman knows that we're in this mode. You have a couple options here. You can do the 20 point HDR or the 42 point HDR, or the LG Dark Detail HDR. Once again, if you have a meter such as the CR100 that can measure quite low, or a Klein, or any of those meters like a Minolta CA310, you may want to use the dark detail to get better performance near black. Any meter that's going to have good response coming out of black may benefit from using the dark detail adjustments. If not, you can always use the regular number of points and perform your calibration that way. We're going to choose LG Dark Detail HDR. We're going to leave our delta target at 0.5 and we'll press OK. Now Calman is going to run through doing the HDR calibration with the HDR insertion and stabilization and build that 1D lookup table and load it into the display. Okay, so the calibration is completed and we've done the 2.2 EOTF in Cal Start for HDR and we're measuring about 961 nits at the peak. Now keep in mind this isn't what we're going to measure when we do the post-calibration readings, but during the auto cal we're measuring about 961 nits, which is quite a bit bright for one of these displays. Let's hit next. Now we need to do our 3D LUT calibration. So we're going to hit auto cal. And Calman's once again going to go through a process of putting up a pattern, taking a reading, and optimizing the data set for the AutoCal process. Now we've got our window up, and you'll notice a couple options here. You're going to see we once again have that start delay if we wanted to add a delay to our start, which we're not going to do here. We also have the set 3D LUT grayscale to Unity. Now, what this means is that, again, we're going to not try to adjust the grayscale when we create the 3D LUT. However, we're going to want to uncheck this for the time being, and we're going to want to create a matrix LUT. So you'll notice that here we have lightning LUT, matrix ramp LUT, the 9, the 13, the 17, the 21 point, and the matrix LUT. What we want to do in Calman is we want to use the matrix LUT to optimize the display. Now part of this is because the display is actually being calibrated in a pure power function of 2.2, and then when we turn off Cal Start, this enable calibration mode, the display is going to use an internal transform to transform the gamma or pure power EOTF into the PQ EOTF and provide tone mapping. And we don't want our 3D LUT to get interfered with that tone mapping and some of the image processing going on. So what we're going to do today is we're going to do a matrix LUT. So we're going to measure red, green, blue, and white, and we're going to provide that into a 3D LUT file that's then going to optimize the display along with the 1D LUT we just created. So let's do that now. We're going to uncheck that Set 3D LUT if you haven't already. We're going to make sure we're in Matrix LUT. We're going to click OK. Now the benefit of this process is it actually goes very quick because we're only measuring red, green, blue, and white and then formulating that into a 3D LUT file that gets loaded into the display. Once that's done, we're going to move on to the next step where we're actually able to tune the tone mapping in the display to optimize our EOTF curve. And we'll talk a little bit more about that as we get to that point here in just a moment. Okay, so the matrix LUT is completed in about 46 seconds with a total read of 5. We're going to hit OK, and we'll press Next. Now, as I was just mentioning, we have the tone curve adjustment. So we can set max luminance by measuring it. So we can hit Measure Max Luminance. You can also use the 961 nits that were measured during the AutoCal process and start with that as a starting point if you'd like. But what you're going to find is during the calibration process, again, this fluctuates just a little bit. So we're going to take a moment to really optimize this tone curve and make sure we're getting the results we're looking for. Here we are at 941 nits. So we're going to take that 941 nits close to the 942. So we'll put in 942 nits there. And then we have these mastering peaks. So you'll notice we have 1,000 nits, 4,000 nits, and 10,000 nits. The LG OLED has 3 different tone curves based on the mastering nits that are coming into it. That's given to the LG OLED via an AVI info frame from your source. So if the display is receiving a 1,000 nit signal, it's going to use that tone curve and perform that tone mapping based on the settings that we set here. If it's receiving 4,000 nits, it's going to use the 4,000 nit tone curve. It's a great way for the display to optimize the roll-off to different levels of content to ensure the most accurate image and the truest artist intent. For what we have here, I'm going to leave these at default, 70, 60, and 50. We're going to hit Tone Map Upload. We're going to hit Next. Now you may have noticed that I've had this white patch sitting on the screen. You may not want to do that in talking to a camera because right now I'm heating up the panel. So when we go to our next page here and we start taking some measurements, we may find that the measurements are a little bit off because we've heated up the panel too much and we're going to have to maybe wait for it to cool down a little bit. We've turned off Cal Start here on the Enable Calibration page. We'll hit Next. Let me go to 0 just for a moment. I expect this to take a little bit longer than just a few seconds, but we'll go to 0, we'll wait a few seconds here, and then we'll hit measure and we'll see how we're measuring. Once again, remember that we are in a very brightly lit studio environment. Let's clear our data in history 1, clear tab data. Now we've got clean data. That was from our last session with SDR. We'll hit read all. It's going to use our pattern insertion, and we're going to go through the read all process to see how our calibration came out and where our tone curve currently is. Okay, so as you can see, our post-calibration readings have now finished. We're getting 926 nits. We're tracking the OTF curve very well. We might be coming out just a little bit high, but remember I was overheating the panel. I expect this would stabilize here if we wait a little bit longer. You'll notice we're getting a 0.6 max delta E with an average of 0.2, and on the color we're getting a max 1.7 with an average of 0.6, and we are measuring in BT 2020. But we can see these measurements are pretty much in the target squares, and this looks pretty good. Now we can hit next. And once again, if you want to do some additional validation, you certainly can go through the additional validation process, save out your report. You'll also notice on the left side of the workflow, we have SDR calibration is now completed with grayscale and 3D LUT. We have HDR calibration completed with the grayscale and 3D LUT. And the next thing to do is our Dolby Vision calibration. So let's hit calibrate next mode. Now there's one more thing that I want to go through for those of you in the post-production community. And it has to do with the P3D65 workflow we were talking about just a few minutes ago at the beginning of this HDR workflow. So in post-production, we have monitors that can't quite hit Rec 2020, and we're trying to master content for Rec 2020 or BT 2020. Well, the problem is if we set the monitor to BT 2020 and we set our workflow to BT 2020, we have the potential of having illegal colors that we can't see getting into the signal. So a common workflow path that people are using today is called P3D65. And P3D65 uses the DCI P3 color gamut along with the D65 white point. It also uses SD2084, the PQ EOTF, and we're able to set monitors to P3, which is often the native of many of these broadcast monitors today, or very close to their native. And we're able to set the mastering system to P3D65. And now what happens is we don't have colors that could be illegal. We can see all of the colors that we're trying to make during the mastering, authoring, coloring process. However, consumers are not getting P3D65 at home. They're getting BT 2020, Rec 2020 content at home. So during the process, we take a P3D65 mastered color space or gamut, and we put that into a Rec 2020 container. Think of it as a glass half full. We have a glass of Rec 2020 color, but we're only filling it up to P3. And then the rest of it just doesn't have data in it. That's one very popular workflow that many of today's Hollywood studios work in. You can also now, with today's modern technology, set the monitor up to BT 2020, set your color grading system or mastering system up to BT 2020, and simply check a box that tells you to gamut limit to P3D65. Then the coloring system will actually cut off any colors outside of P3D65 and only fill that glass half full. So it's two ways to get to the same result. And it really depends on the workflow that you're working in, the tools you're using, and what your deliverables are in terms of what you're going to use and how you're going to approach this problem. So I'm going to show you now how I would approach the problem if you're trying to set up your LG OLED for P3D65 in a production workflow. For those of you at home calibrating for a consumer use case, this is not something we recommend you do because it could only cause more trouble than you're looking for because the monitor could get into the wrong mode. Here we go. Let's go back to Calman, select HDR Calibration. Now we've already set up our system for HDR and we've already done 2020, but the monitor has a second memory based on its color space flag. So remember we were talking about the info frame flag that content sends to the display to say, I'm 1,000 nits, I'm 4,000 nits, I'm 10,000 nits. There's also a colorimetry flag in the AVI info frame that tells you if the content is BT709 or BT 2020. And the LG OLED has two memories. If it sees BT709, it goes into a BT709 memory. If it sees BT 2020, it goes into a BT 2020 memory. What we're going to do is we're going to tell the LG that we're sending BT709 HDR, which isn't really a standard because BT709 is an HDTV SDR standard. Therefore, we're going to trick the display by sending P3D65 content down a BT709 flag and calibrate the BT709 memory to P3. I hope you're not too confused. Getting a BT709 flag, going to a P3D65 calibration. Generator is going to send a BT709 flag, which triggers it into that P3D65 mode. On many of today's color grading systems, when you set up a P3D65 workflow, the HDMI output of these professional cards will actually automatically send a BT709 flag. So if you're a colorist and you're using something like DaVinci Resolve with a Blackmagic 4K output card or a 4K Ultra Studio Mini, you'll be able to set up your timeline for P3D65, and the output of the card will automatically send the BT709 flag, which will automatically put the display into P3D65. If you set up your timeline, your workflow for BT2020, the display will automatically go into BT2020. But there are some caveats. You cannot be using a converter or a router. So if you're outputting SDI or serial digital, you're not going to be able to have this work. If you're going through a switcher, a router, a converter, like many studios do in large environments, it's also not going to work. So we'll walk through how you can manually adjust this in those situations after we go through the calibration. Let's do it. So we've selected BT709, which is going to tell the display I want to write to the BT709 memory. But I also have a couple other things I need to do. I'm going to go up to my SpectraCal VideoForge Pro. I'm going to come here and I'm going to select HDR because it turned off when I went back to the start of the workflow. And you'll notice there's a BT2020 checkbox here. What this is saying is I'm sending a BT2020 info frame flag. We're going to turn this off. When we turn this off, you'll notice that the display flickers and it's resyncing to that new flag. So now it's still in the HDR mode if you look in the top right corner, and we're sending that 709 flag. So I'm telling Calman here to write to BT709. I'm telling the generator to send a BT709 flag, but I'm also in HDR and I'm in the HDR cinema mode. The next step I want to do is I want to hit next and go to my targets. Well, now I want to calibrate to P3D65. So I'm going to leave this in D65. I'm going to set this to DCI P3. It may change your white point, so we may need to set that back to D65. We'll just keep an eye on it. Keep in mind if you're also working in your own workflow or a different workflow, you may want to be careful of what's going on because often some color spaces in Calman are tied to white points and some color spaces are not. Depends on the workflow and how you're working. So always keep an eye out for your white point because DCI uses a different white point than D65 by default. Okay, so we're in the custom white point, which is 3127329 with a DCI P3 space. So we are in D65 P3 in our workflow. So we've set our generated output 709, we've set the LG to be written in the 709 mode, and we've set Calman to P3D65. Now we'll hit next. We're still in our HDR Dolby Vision default, but if you'd like to hit it again, you can. You'll notice nothing changes. Now we'll hit next. We can do a pre-cal, but I'm not too worried about the pre-calibration. We'll hit next. We'll stay in our HDR cinema. We're not going to reset the HDR cinema. The 1D LUT is shared between the BT2020 and the BT709 memory. The only thing different is the 3D LUT. The BT709 LUT or the 2020 LUT. With the BT709 LUT, we're gonna write the P3D65 LUT. So let's move forward in the workflow. We'll hit Enable Calibration, turn on our Cal Start. We're going to go up to the DDC controls for the display. We're going to arrow over to the 3D LUT, and we shouldn't have to, but we're going to hit Reset 3D LUT just to be sure. I'm going to reset that 3D LUT in the 709 mode. Now, it should have been reset when we did the full DDC reset, but just to be safe, I'm going to reset that now. I'm going to hit Next, skip over the 1D LUT, and go to my 3D LUT. We're going to hit that Auto Cal. And once again, we get our pop-up. We have no set 3D LUT grayscale to Unity, which is correct, and we're in our matrix LUT. We'll hit OK. Now Calman's going to run through measuring the display, correcting it to P3, and loading that into the 3D LUT slot. The final step, we'll want to validate this. This memory uses the same tone curves that we were using for 2020, so you don't have to redo your tone curves because the 1D LUT is shared. It's really just that 3D LUT that we're going through and optimizing for P3. Okay, so we've done the matrix LUT. It's taken 46 seconds, 5 reads. Now we can go to next. We're going to leave our tone mapping. We'll hit next again. We'll uncheck our calibration. You'll notice the colorimetry is off here, but the EOTF isn't because we're targeting a different color space. So we can come here and we can clear our tab data. And now we can measure the grayscale EOTF. And what we should see here is we should see that the grayscale is measuring nearly identical. Once again, we're in a very bright studio environment, and we're going through this fairly quickly, but it should measure similarly to the BT2020 EOTF and grayscale, and we should be measuring the P3 color at this point in time. Okay, so as you can see, we finished the calibration. You'll notice the EOTF and grayscale is tracking nearly identical, 0.7 with a 0.3, 0.9 max on the color with a 0.4. You'll notice this curve maybe even got a little bit better because the panel has cooled a little bit since we've been talking. We're hitting 930 nits on the output. So this G2 is doing excellent with its luminance. And again, we are hitting the calibration targets now for that color. So if we come here and we take a quick look, you'll see we're in custom 1, SD24, and we're not in 2020. Now, if I hit 2020, what we're going to see here, if we go back to BT2020 HDR, we'll notice the colorimetry doesn't match on the computer. And the reason it's not matching is because we've calibrated for P3D65. So we've done our first calibration in BT2020 with BT2020 on the display. We've done our second calibration for HDR for P3D65 when in the BT709 mode. However, while we're able to send that info frame data from our generator, and while many professional systems will send that data, I did mention that in certain situations where you have a switcher or a router, you may not be able to do this. Well, how would you change your mode? There's a couple ways you can do this. One, you could calibrate a different picture mode in the 2020 space, but target P3. If you were to do that, you could just tell your user to change the picture mode. So for example, you could calibrate the cinema mode for BT2020 and then calibrate the filmmaker mode for P3D65. Then it doesn't matter what flag you're sending because you've calibrated them in the 2020 space for each respective standard. If you don't want to do that and you want to stay in that cinema mode, you can also force the issue. So we can go to Picture, select HDR Select Mode, and with this highlighted, when you're selecting HDR Select Mode, you want to go to your remote and you want to press 1113111. Now, this is taken into what's called an HDMI signal override mode. What this mode allows us to do is go through various parameters and force the display as if it was getting the data from the source. This is a great way to test certain situations and see what might be happening to troubleshooting issues in the studio environment. Again, for people at home, you're never going to really need to use this. It's going to be a very straightforward calibration. The modes aren't going to change, but in that studio post-production environment, there is a use case where this is very important. So if you were to force this, you'd want to take your colorimetry setting here, use your arrows, and change it. So BT709 is going to be that P3D65. There's also a BT601, a BT2020, and a P3D65. Here's where it gets very confusing. There's actually no AVI info frame flag that we can send that designates P3D65, but it's in the menu. So it gets very confusing because a lot of people might think you want to select P3D65 because that's what you're targeting, except we can't write to the P3D65 memory on the TV. It's just something that's in there as a placeholder. So ignore the P3D65. You either want to be in auto, forcing BT709, once again your P3, or setting BT2020 for BT2020. Again, this is only if you can't send your AVI info frame flag for the colorimetry. If you can, you want to keep it in auto. Also be careful if someone's changed this and you start to switch modes. If you go back into SDR or you go into a different project, you may want to check this because this is forcing the input into that. That's another nice trick. This is forcing the input. If you were using 2 inputs, you could force one HDMI input and not the other. That way you can switch between inputs for your HDR, SDR, or your BT2020 and P3D65 workflow. There's a lot of versatility in the LG OLED, allowing the display to fit many workflows from many discerning users. Choose the way that works best for you. We're going to keep this in auto and back out. We've now calibrated both the SDR and the HDR modes, and we've done the HDR mode for both P3, D65, and BT2020. Now let's take a look at our last mode, Dolby Vision. Let's go back to Calman, and I'm going to use a shortcut here, click on the top left to get to my workflow layout, and hit Welcome. I'm going to select Dolby Vision now that I'm back at the start of my workflow, and I'm going to go through the process for selecting Dolby Vision. We'll want to make sure we're not in HDR10 mode from our VideoForge Pro. We'll start in SDR mode and then send our Dolby Vision flag. Sometimes displays might get a little confused with the flags coming at them so quickly from the generator. So I always like to go back to SDR, then jump to Dolby Vision, or SDR, then jump to HDR. That way the flags are fresh and we don't get any incompatibilities that may occur. It doesn't always occur, but it's a nice tip just in case you start running into issues. So now we're going to go back to our generator. We're going to set this to Dolby Vision. We'll double check that Dolby Vision, we're perceptual. We've got our HDR box checked just as the instructions say down below. We'll hit Next. We're waiting for the display to sync. The display has lost sync because we've changed the flag, and it'll come back here in just a moment. Preset targets, we'll hit Reset. But we want D65, P3, ST2084. Hit Next. Okay, and now on this page, you'll notice that Calman is instructing you to check if the display has properly gone into Dolby Vision. There's a couple ways we can do that. One, we see the image is white and not like the red that we're seeing on our Calman. The other way you can do it on an LG OLED is you can hit the settings button, and once again, look at the picture mode. You'll see the picture mode says Dolby Vision Picture Mode. That lets you know that the display is in Dolby Vision. And if you happen to be watching the TV when it went into Dolby Vision, you'd also see the Dolby Vision signal here in the top corner as it switches. And now you'll notice that this says, check that your generator is set for absolute Dolby Vision. We're going to go up to the SpectraCal VideoForge Pro. We're in perceptual. Let's set this to absolute. This changes the metadata and how the display is going to map the video signal coming in on the display. We're once again on our pattern insertion setting. You can always hit Set HDR Dolby Vision Default, but we haven't changed it. We'll press Next. And now let's take a reading of Dolby Vision pre-calibration. All right, so the pre-calibration ratings have finished. We'll notice we're actually tracking an EOTF a little bit higher than we'd like. The grayscale isn't terribly far off, but that EOTF is really showing us a boosted performance. And the colorimetry is actually pretty close overall. I think what we're seeing here in this error has to do with the luminance error here. In fact, if you want a quick trick, you can right-click on a chart in Calman, hit Properties, and then come over here and come over to the Include Luminance Error. If you take the luminance error out, you'll see where the colorimetry error is, and you'll see this came way down, showing that the luminance error is actually what is boosting the delta E higher. Okay, let's hit Next. Now again, we want to select our picture mode, so we're going to go to Dolby Vision Cinema. We have Dolby Vision Cinema Home, Dolby Vision Cinema, and Dolby Vision Game. Once again, I want to do everything just for the purpose of this demo in the cinema mode, but you can calibrate any of the modes, and Calman will do an excellent job no matter what mode you're calibrating. We've selected Dolby Vision Cinema mode. Let's hit Reset. This is going to enable that calibration start menu you see on the bottom. It's going to go through the reset, and it's going to prep us for our calibration process. But there's going to be one more thing we need to do, and that's going to be setting our generator up for the right metadata in Dolby Vision to perform the calibration. And you'll notice here in the workflow, it says for Dolby Vision calibrations, the pattern generator metadata must be switched from absolute to relative. So as soon as my display is done being reset, we're going to set that to the relative setting. Set it to relative in the generator. You'll see a change on the display. Hit Next. And now once again, we're going to hit that Auto Cal button. It's going to go through its process again, measuring the range, put up some options, and we'll do our calibration. Here we are with our LG 20 points HDR. Now again, we can just calibrate the default, or I'm going to go, because I have a CR100, down to that LG Dark Detail HDR, Delta E target 0.5. If you'd like to go tighter, you can. It's just going to take longer. We'll hit OK. And now the calibration process is going to run. It's going to go through that 1D LUT for Dolby Vision, and then we'll move on to the next phases. Okay, so as we can see, the 1D LUT for Dolby is finished. It took 21 minutes, 59 seconds, and 142 reads. Once again, I always like looking at what the luminance was. We were hitting about 941 nits, similar to the HDR calibration, and it looks like we were tracking the EOTF of 2.2 pretty well. Let's hit next. Now the next step in calibrating Dolby Vision is to create what's called a Dolby Vision config file. And that's essentially doing the color gamut mapping for Dolby Vision. It's not quite a LUT because it utilizes Dolby's processing, but we have to tell Dolby's processing where the display's characteristics are in order for it to do the color management and optimize the display for Dolby. To do so, we're going to click on Create Dolby Vision Config. We're going to tell the system where to write it. I'm just going to write it to my desktop. So it's going to take a few measurements, just like a matrix LUT. It's going to write those to the desktop, and then the next step is going to be importing that into the TV and performing our validation. Okay, as you can see, the file has successfully been written to the desktop. We'll hit Dolby Vision File Upload On. I'm going to select the desktop, choose Dolby Vision Config, open. The red means it's writing. We'll hit Next. Disable the calibration mode by unchecking Enable Calibration. And now we're going to want to change our metadata back to absolute from relative so that we can measure the post-calibration results in PQ. We hit Next. And once again, I'm going to right-click on History 1. I'm going to clear our tab Data so that we have a fresh start. And we're going to hit Read Series in the bottom right. Now Calman's going to go through measuring the EOTF and color gamut as it has in our previous examples, and we'll see how well Dolby Vision calibrated. Again, I want to emphasize we are in a bright studio environment. We don't expect these results to be perfect, but as you've noticed, we are getting great results going through this process, even in a brightly lit room. Okay, once again, we've finished our post-calibration results with Dolby. We're seeing excellent results again, tracking the PQ curve. Our max error here is a 1 with an average 0.5. A max on the color is 1.4 with an average of 0.8, and we are hitting these color targets. We can hit, and we're hitting 936 nits, similar to what we were doing in HDR. So we hit Next, and as you can see on our workflow, the SDR has been completed, the HDR has been completed, and the white balance. You can always do the additional validation, go to calibrate another mode, another picture mode such as Dolby, or save your report. Now there's another thing I like to do when I calibrate these LG OLEDs, and that's copying the settings from one input to the next. So once you calibrate a display, not just with LG, but with many displays out there in the field, you'll notice that calibrating one input doesn't necessarily apply to the next input. They actually have separate memories. So if we come here to all settings, one of the easiest things to do is to make sure you're in your picture mode, to come down to advanced settings, and to hit apply to all inputs. Now, just because you're hitting apply to all inputs doesn't mean every setting copies to every input. So it's important to go through the settings on each input and make sure that they've copied over. And it just depends on the manufacturer, the model, the firmware as to what's going to copy. You'll want to do this for SDR, HDR, and Dolby Vision. You'll want to hit that apply to all inputs. Then the next step is to go to the other input and select the mode you're in. So for example, just because I've copied Dolby Vision Cinema from HDMI 1, let's say, to all the inputs, when I go to HDMI 2, I might not be on Dolby Vision Cinema, I might be on Dolby Vision Game. So those settings are different currently than what we calibrate in Dolby Vision Cinema. So you'll ultimately want to go through each input, do SDR, HDR, and Dolby Vision, and you may also want to check your apps because the apps often are a separate input and need to be set up separately. So you want to make sure those are also in the SDR, HDR, and Dolby Vision mode that you've calibrated. That's all for our LG video today. I hope you enjoyed it. For more information, visit portrait.com. Thank you.